Hello, my name is Manar Magdi, and today we're going to start the first session in the course Operations Research for the fourth year. That the first topic in our course is Chapter 14 during the Pert Network. In Chapter 14, we're going to learn how to draw the Pert Network using the regular time, determine the earliest allowable time and the latest allowable time and the slack time of each event, determine the critical path and the project time, determine the cost of the project, determine the project crashing time, determine the additional cost per day saved and the allowable crash time for each activity, and how to determine the successive plan that will help in finishing the project in the shortest allowable time possible. It's going to be easy. It's not too hard. The main aim behind Pert Network is to draw a plan in order to start and finish a specific project. Each project consists of a set of activities or events. The events are given like a name, either like excavation event or so, or it is written activity A, activity B, and we're going to learn each of these objectives successively. It's not too hard, just take it one step at a time. Let's start. We are going to solve today question number 3 in final exam 2013. Okay. In question number 3, you're given a specific project and you are given the activities. As you can see here in the column activities and events, you have got here 6 activities, and you are given how each of these activity connects between a specific number of events. For example, here activity A connects between event number 1 and event number 2. Okay. And you are given here the regular timing that this project can use, and you are also given how each of these activities or events can be crashed to a specific number of days. Okay, and you are given the regular and the crashing cost. Okay, the requirements: try to solve only what you are required. Okay, let's start. Let's see the requirements. Okay, in number 1, you are asked to sketch the project Pert Network using regular timing, and you are also asked to calculate the earliest, latest, and the slack time of each event. We have studied how we can calculate the earliest, the latest, and the slack time in the previous session. We're going to see it in this example. Okay. In the first requirement, you are asked to draw the Pert Network. Activity A connects between the event 1 and 2. It means that it starts at point 1 and then ends at point 2. And this takes 18 days regularly. In the regular time, this event, for example, like the excavation, we're looking for gold, for example, in a piece of land, and activity A stands for example, excavation, and it starts at point 1 and ends at point 2, and this usually takes in the regular time 18 days. So you will draw a straight line starting from point 1 to point 2 and write under it activity A, and it takes 18 days. Then we're going to continue to activity B. It connects between event 1 and 4. So you will draw a straight line starting from point 1 again, and then extend it to either upwards or downwards. It's up to you. Just if you take the upwards or downwards, just continue the Pert Network in a format that looks organized. Okay, so activity B, which takes 22 days, it starts from event 1 and ends at event 4. And then we will see that the third activity, which is C, it starts from point or event 2 and ends at point or event 3. So we will extend a straight line from point 2 and then write that activity C, which takes 26 days in the table given in the example. And then activity day starts from point 3 or event 3 and ends at event 5. So you continue that event day starts from point 3 and ends at point 5. And then it takes 26 days. Then event E starts from point 2 and it connects between point 2 and 4. So we write that activity A, which takes 24 days, starts from point 2 and ends at point 4. And then activity F starts from point 4 and connects between 4 and 5, and F takes 30 days. Okay? Here you can see the Pert network using the regular times. You can sketch it using the regular days given which are given in the beginning of the problem. As you can see here, activity A, which has stated that it connects between event 1 and event 2, and then activity B, which connects between event number 1 and event number 4. And activity C, it connects between event number 2 and event number 3. And activity E connects between 2 and 4. And D connects between 3 and 5. And 4 connects and activity F connects between event 4 and 5. And here are the regular days are written above the activity. Then you are supposed to calculate the earliest, the latest time, and the slack time. In the second requirement, we will take it step by step. First, we'll start by the earliest time. The earliest time, it is the maximum time or the longest time you can take in order to start the event. And after this point, the event is going to be very late. So it is the maximum time that you can have in order to start this project. For example, event number 1, the earliest time for it is always 0 because it is successive. The time at which you have to start is like right now. So right now is the point 0. And from here you go on. In order to calculate the event, the earliest time for the next event, you add the earliest time for the previous event plus the number of days of the activity between them. For example, here we're going to calculate for event number 2. We're going to calculate the earliest time. So it is equals to 0 plus 18, which is the so in order to calculate the number of days for event number 2, you have to add the TE for event number 1 plus the number of days on the straight line for activity A, which are 18. So the number or the earliest time in order to start event number 2 equals to 18 days. Let's continue to the next event. We have for event number 3, the earliest time for the previous event was event number 2 because it has only one hand getting into it. So 18 plus 26 days on the straight line equals to 44. Let's continue. For event number 4, which is the next event, you will notice that you have got two preceding events. We have got event number 1 and event number 2. So here, in order to calculate the earliest time for event number 4, you have to choose. How can I make this choice? First of all, you calculate the two choices. For example, here in event number 4, we have got the event number 1 and event number 2. So we'll calculate the earliest time for the event number 1, which is equal to 0 plus the number of days for the activity between 1 and 4, which are 22 days. Then we get the total amount for the earliest time is equal to 22. And if we calculate the other choice, which is 18 days for the earliest time for event 2 plus the 24 days for activity, we get 42 days. So in order to, if you have got if you face this same situation where you are supposed to calculate the earliest time for the same event and you've got two choices, like two heads, two arrows with two heads getting into the event. You choose the direction or the arrow with the largest total earliest time. Okay, so here we'll take the 42, which comes from event 2 and activity E. Okay, let's continue to the next one. Here we have got for event number 5, which is the last earliest time we have to calculate. You're also facing the same situation, two choices, and you choose the one with the largest amount, which is 72 days. Okay, let's continue to calculating the latest time. The earliest time for event number 1 is 0, because it is your starting point. And then event number 2, you in order to calculate its earliest time, you add 0 and 18, which is equal here 18. You write it in the square. And then for event number 3, you've got only one arrow entering it, so you add 18 plus 26 equals 44. And for event number 4, you have got two arrows entering it. You've got earliest time, which is 22, or 18 plus 24, which is equal 42, and 42 is greater than 22, so we have chosen it as the earliest time. When you calculate the earliest time and you've got two choices, you choose the biggest number. Then for event number 5, you also have got two arrows entering it, so I've got 44 plus 26, or 42 plus 30. So we have chosen 42 plus 30 because it is greater, which is equal to 72. Then the next step, you are supposed to calculate the latest allowable time. So you start from the end to the beginning, which means that you start from the right hand side or event number 5, and then you go backwards till event number 1. In order to calculate it, you start by event number 5, or the last event here. The latest allowable time, it is calculated by the latest allowable time for the event minus the activity. For example, here for event number 5, the latest allowable time is the same as the earliest time, because it is there is no no TL or no allowable time after event number 5. Okay, then go backward to event number 4 and 3. As you can see here, we will start by event number 3, as it is the easiest. You can calculate it by the latest allowable time for the event it comes from. How can you know it? Through looking at the arrow, the end of the arrow. There is only one end entering to event number 3. So the latest allowable time for event number 5, which is 72, minus the number of days for the activity connecting between them. So the TL for event number 3 is 46. And for event number 4, you can see here that you've got only one tail for an arrow entering it, so you calculate it in the same way. If we look at event number 2, here you have to choose. You've got two ends, two arrows and two ends into entry or coming out of event number 2. So you have to choose which TL to take. Okay, so you do calculate the two options, and you have to choose. For example, here, if you take the TL of event number 3 minus the number of days for activity number C, you'll find that the TL in this case equals to 20. And if you take the TL coming out of event number 4 and then number of days for activity number E, you'll find out that the TL here is equal to 18. So if you have two choices when you're calculating TL and you don't know which one to choose, then you have to choose the smallest number. You've got 18 and 20, so 18 is smaller than 20, so you choose it. And if we go to event number 1, the TE for it equals to You also have two choices, two arrows coming out of it. So you make the same choice, and the first choice that comes from event number 2, 18 minus 18, and the difference equals to 0, and 42 minus 22, the difference equals to 20. So you choose the smallest one equals to 0. Okay. The last thing that you're supposed to calculate is the slack. I'm sorry, here it is written wrong. It is TL less TE, not the otherwise, because the slack is always equal to 0 or a positive number. So here for event number 1 equals the TL0 minus TE equals to 0, then the slack equals to 0. If we continue to event number 2, 18 for the TL, which stands for the TL amount, that's the TE, also equals to 0. For event number 3, if you subtract 44 from 46, then the slack here equals to 2, which means that you can, there is like a space of time between these events. Like you can, it stands for the amount of time between those events, like how much time you can not start or not work away or so on. Like for example, here for event number 1, there is no time to waste. Here you can have 2 days between those the start and the end. Okay. Then continue for event number 4, 42 less 42 equals to 0, and for event number 5, the same thing. So let's review this quickly. Okay. Then you calculate the latest time, which is the same as for the last event here 5. The latest time equals to the earliest point or the earliest time, which is 72, and the slack is the difference between both of them, which is equals to 0. And you continue in the same manner. Before we continue to the next requirement, you can observe that the critical path is the connection between the events that have got a slack value equals to 0. So I've got here event number 1, the slack value equals to 0, and 2, the slack equals to 0, because it is the difference between 18 minus 18. In order to see how you can identify the critical path more step by step, let's start here. Like if you start from event number 1, here you can find that the slack equals to 0, and the next event you've got either 2 or 4. At 2, the slack here equals to 0, while at 4 it is equal to 0 also. So you have got to continue from event number 2 to event number 4, and not to 3, because 3 here the slack equals to 2. Okay, so if you continue from 1, that is so activity 8 is one activity on the critical path. Then we decided not to continue to 3 because the slack here is not equal to 0, but at 4 it is equal to 0. Then we have to continue at 5 because the slack here is equals to 0 also. This is one way to get to know the critical path by eye, and you can also know the critical path through calculations, and we'll see this in the upcoming answers. Okay. So let's revise quickly the main rules that you should understand for the TE and the TL and the slack. The TE stands for the earliest possible time. In order to calculate it, you have to take the TE or for the previous event plus the number of days of the previous activity. And notice that you have to, if you've got a choice like 2 paths or 2 arrows in front of you, you have to choose the largest. And for the TL, it stands for the latest possible allowable time. And it means that you cannot not start the project after this point of time, after the number that you get. In order to calculate it, you always take the TL for the activity after or for the event after the one you are calculating. Okay, less the number of days or the activity between them. Okay, and you have to notice to always choose the smallest one and to go backward or descending from the end of the project to its beginning, and while the TE you go from the beginning till its end. Okay, And the slack, it is the time with which we are allowed to be delayed on the event without changing the project time. It is like a space of time between the start and the end. Okay, it stands for TL, that's the TE. Okay. And the critical path, it is equal to all the slack variables or the events where you can find the triangle or the slack equals to 0, and it is the longest path. Thus, we can be delayed more than this. We can deliver the final product after the time of the critical path that we can calculate it. And you can get it through your eyes, like by looking at the times where you find the slack variable equals to 0, or you can calculate it in the way that we are going to show you in the next slide. Okay, so let's review what we have done quickly. You can see that event number 3 was the only event the only event that had a slack value not equal to 0. The slack value here is equals to 2 because it is 46 minus 44 equals to 2. You can see that 4 also has got a slack value equals to 0, and 5 equals to the slack here equals to 0. We can assure ourselves that this is the right critical path by calculating it. How we can do that? As you can see here, in requirement number B, we have got to read it first. What is the critical path and how long is this project going to take and how much will it cost? So we're going to calculate the critical path. We have got several paths available in order to calculate the critical path. The first path is ACD, the second one is AEF, and the last one is BF. In order to calculate the number of days of each path, ACD, the regular timing is 18 plus 26 plus 26 equals to 70. E equals to AEF equals to 18 plus 24 plus 30, which is equal to 72, and BF equals to 22 plus 30 equals to 50. The largest or the biggest amount of days given is in the path A, E, and F. And we have said before, it is the intersection between the events that has a slack value equals to 0, which is correct. So we are moving in the right direction. Secondly, we're going to calculate its cost. It is the summation of the total direct cost in the given in the regular path. Okay, so if you return back to the given table, you are given the regular direct cost, which is 1000 for activity A, 800 for activity B, 600 for activity C, 1400 for D, 1200 for E, 1000 for F, which is equal to $6,000. We're going to move to the next. In requirement number 3, you are asked what is the project crashing time. You can calculate the project crashing time through focusing on the available paths and calculating them using the crashing timing given in the first table in the problem. Okay, our critical path was AEF. The new critical timing equals to 18. 22 plus 24 equals to 64 days. In the regular time it was 18 plus 24. You can see here that in the crashing it has decreased to 22, and 30 it has decreased to 24. So the 72 days has decreased to 64. And you can also calculate the rest of the paths in order to see that they have also decreased and have been affected by the crashing timing. You can see that ACD equals to 18 plus 24 plus 22 equals to 64, which is same as the critical path given in the regular timing. So don't panic. You can get a new or two critical paths in the crashing timing. It is not unusual. And BF equals to 44. Requirement is that you are asked to determine the additional cost per day saved and the allowable crashing time for each activity. And you draw a specific table in order to calculate them as follows. The table that we have mentioned that you are going to use, it includes 3 columns. The first column includes the activities A, B, C, D, E, and F, and they are given with the events that they connect. Okay. The next point is that you draw the second column, which states the additional cost per day, which is equal to the change in the cost or divided by the change in the timing. And the last column is the allowable time. How we're going to calculate it? First, the additional cost per day equals to the change in the cost divided by the change in the timing. The change in the cost is calculated by deducting the regular cost from the crashing cost. And in order to calculate the change in the time, you deduct the crashing days from the regular days. And you can get these values from the first table given in the problem. Okay, so you can see that for activity number A, we have deducted the crashing cost minus the original cost or the regular cost. In this activity, by coincidence, it is the same. So you can just say that it is equals to 0 and that we are not going to use it. And the change in the timing equals to 18 minus 18. So we're not going to depend upon activity number A in the next requirements. Okay, but you have to solve it. In activity number B equals to 1200 minus 800 divided by 22 days minus 20 days equals to 200. Activity C, the allowable cost divided by the days equals to 200, and in D equals to 100, E equals to 300, and F equals to 100. The allowable time equals to 0 because 18 less 18 equals to 0. 22 minus in B, 22 minus 20 equals to 2, and in C, 26 minus 24 equals 2. In D, 26 minus 22 equals to 4. E, 24 minus 22 equals to 2, and in F, 30 minus 24 equals to 6. Ignore this amount, it is for the next tables. Okay, let's continue to the next requirement. In the last requirement, you are asked what are the successive plans that will help in completing the project in the shortest time possible, the project crashing time. Determine the associated cost of each plan. So after we have prepared our calculations, starting from requirement number 3 and 4, you have calculated the project crashing time, you have calculated the additional cost per day saved and the allowable time for each activity. Using this information, you can suggest successive plans in order to crash this project, and we are going to see this next. So we're going to suggest several plans in order to reduce the project timing or crash the project. Okay, we've got the available. First, you start by writing your available paths, which are AEF, ACB, and BF. Okay. The plan number 1, which is the regular timing, is that AEF takes 72 days, ACD takes 70 days, and BF takes 52 days. Okay, so plan number 1 is to do nothing. Then we're going to suggest the second plan. Okay, plan number 2. Our critical path using the regular timing was AEF. Okay. From the previous table in number D, we have calculated the additional cost per day. Okay, the critical path AEF consists of activity number A, which has got you can't calculate which has got 0 additional cost per day, so it's not applicable. So we're not going to use it. That's why we said in the previous point A is not. We are not going to take it into our consideration. The next activity is E and F. We've got them right here, E and F. The additional cost per day for E is 300 and for F equals to 100. Which is less costly to us is activity number F. So we're going to choose to crash F. By how many days? The allowable time or available from activity number F is 6, which we have calculated them right here. Okay, but if we crashed F by 6 days right away, it is going to make us lose our critical path, because if we crashed F completely, the 72 days minus 6 equals to 66, which makes the critical path AEF less than another path available, which is not a critical path, which is ACD. So we have first to reduce the critical path AEF to an amount closer to the next path, which is ACD. So we're going to crash F first by 2 days. Okay, so here we have deducted from the 2 days, which results in remaining 4 days. Okay, so we're going to say that plan number 2 is that we're going to crash F by 2 days, which will result that the days available for AEF equals to 70 days, and then ACD 70. So they are closer to each other, they are equal to each other. And BF, we're going to reduce it also by 2 days, then it will result into 50. Then we can suggest a new plan is that we continue reducing F, because right now we've got 2 critical paths, AEF and ACD. That is number 1. Number 2 is that we're going to continue reducing F because it is lower cost than E. Okay, so we're going to reduce it by the remaining 4 days. So we're going to crash F by the remaining 4 days. Then we're going to look at ACD. Okay, we have got here C and D, and we're going to ignore A as we have said before. C, the additional cost per day is 200, and for D, the additional cost per day is 100, so D is less. And the available days here are 4, so it is more convenient for us to use D, because the days are equal to F. Secondly, it is also lower in cost. So we have got here AEF, the 70 days minus the remaining 4 days equals to 66, and then ACD also equals to 66, and VF, it is also going to be reduced by the 4 days that we have crashed in activity F, so equals to 46. Then is there more available activities that we can crash? Yes, we have got 2 critical paths here, yes. AEF and ACD, and A is not taken into our consideration. We were taking into our consideration E and F, and then C and D. We have crashed F completely and D completely, so we're going to move to the next available activity that we can crash, which are E and C. E, additional cost per day equals to 300, and the available days are 2. And C, also the additional cost per day is 200, and the allowable time is 2. So the time in both cases are equal. So we are going to crash 2 days from E and 2 days from C. So AEF will decrease from 66 to 64, and ACD will decrease from 66 to 64, and BF will not be affected because we are crashing E and C, and is not included in the path, so it will remain the same. Okay, then we are supposed to calculate the associated cost. How we're going to do this is that we write our available plans. Plan number 1, we have got 4 plans that we have suggested. Plan number 1 is that we do nothing, right? So the project time was equal to 72 days. Secondly, the cost equals to 6,000, which is the original cost, which we have calculated it at the beginning of the problem. and the critical path here was AEF. And then in plan number 2, we have suggested that we crash F by 2 days, so it decreased the project time from 72 to 70, and the cost 6,000 has increased by 200, which is the cost of activity F. Each additional cost per day is 100, and we have crashed it by 2 days, so 2 multiply 100 equals to 200, so 6,000, which is the original cost, plus 200, which is the additional cost that we have calculated from crashing F by 2 days, equals to 6,200. And it has resulted into 2 critical paths, which are AEF and ACD, so we're going to write them here. And then in plan number 3 is that we also start from the last point, is that the cost right now is not 6,000, but it is 6,200, right, from plan number 2. And the number of days will decrease by, we have crashed F by 4 days, right, and D by 4 days also. And each day or each additional cost per day equals to 100 from F, and the number of days were 4, plus 4 days from activity number D, and each additional cost per day equals to 100. So the summation of both of them equals to 800. So 6,200 plus 800 equals to 7,000. And the 70 days from plan number 2 were decreased to 66. How did we do that? In that we will decrease it by 4 days. And the critical paths remained AEF and ACD. And in plan number 4 is that we start by the cost from the last point on the last plan, which is 7,000. And we have crashed E by 2 days and C by 2 days also, and each of them activity each additional cost per day equals to 300, and for C equals to 200, and the summation of them equals to 1,000. So 7,000 plus 1,000 equals to 8,000. And the 66 days for both critical paths AEF and ACD were decreased by 2 days, so the new crashing time is 64. You notice that the 64 days were equal to the crashing time that we have calculated in requirement number C or requirement number 3, okay? And AEF and ACD from the calculations also in this point showed that we are going to get 2 critical paths, if you can remember. We'll see them here. Is that when we calculated the original critical path AEF, the crashing time for it was 64, but when we looked at other paths, we have noted that ACD will get also the same amount of days. So it made us notice that we're going to get 2 critical paths and not only 1. Okay? So right now let us make a quick review for chapter 14. Chapter 14 can be divided into 2 parts. Is that you draw a Pert network using the original timing, and then you can determine your critical path using 2 methods. You can use drawing through the sketch, through following the events that has a slack value equals to 0, and you can assure yourself more precisely using the calculations for calculating the critical path as follows. And if you have got several paths, you choose the critical path using the path that has the greatest amount of days or the largest amount of days. Okay. Second point, or the last point in the original Pert network, using the regular cost, I mean, is that you calculate the cost for the project using the regular cost given to you. Okay. Then you are suggested that you should crash the project from the regular days to the crashing days. How we do that is that first of all we also start by writing all our paths that are available, okay, and you calculate the crashing time or the project time using the crashing days given in the table. Okay, then you have to calculate in order to know how you can suggest several plans in order to crash your total project, is that you have to first write your activities in this following table. You write your activities, and then you calculate the additional cost per day, and then you write your allowable time, and then you start suggesting several plans. Your plan number one is that you do nothing, which is the regular plan. Okay, and then you start by crashing the activities one by one according to their cost. Okay, you start by the critical path, and then you follow the activities involved in it with the lower cost as follows. Here we have started by F and not E. Okay, and make sure that you don't crash the critical path totally and make it lose its priority, as in this example here we did not crash it at one step. No, we crashed it at 2 times in order to not lose its priority over ACD. We have crashed it until both paths were equal to each other, so we have gotten a new result suggesting that we have got 2 paths that we can use, and starting from this point we started crashing them equally. As you can see here, we crashed them 70 and then 66 and then 64 and so. Don't forget to, if you are crashing here an activity, try to crash it also in the next in the other paths. Don't forget them. Okay, and write in detail what you are doing and which path, which activity you are crashing by how many days, in order not to forget. Okay, and then you calculate the associated cost by writing your plans, the cost, which is you start from the regular and then you add to it the cost of crashing. Don't forget your time, you can get it from here, and also you write here the loss crashing from your plan that we have written here in detail. Don't forget to calculate your additional cost, which are the number of days multiplied the additional cost per day. Don't forget to write your critical paths. Okay, and that's it. So at last, in order to do a quick review for Pert, several points that we have to take into our consideration, and that the TE, which stands for the earliest allowable time, if you have got 2 choices, 2 arrows coming out of an event, and you don't know which one to choose, always take the largest, and when calculating the TE you have to always move forward. And when calculating TL, which stands for the latest allowable time, you have got 2 arrows coming out of an event, and you always calculate it like by looking at the tails of the arrow. If you've got more than one tail or more than one arrow coming out of the event, and you don't know which one to choose, always choose the smallest and move backward, which means that you move from the right hand side to the left hand side, or from the end of the project till the beginning of the project. Okay, when the TE, you move from the beginning of the project or event number 1 till its end successively, like by increasing in ascending order, while the TL moves backward or in a descending order. Okay, the TL, in order to calculate it, it equals to the TL minus TE, or the latest allowable time for the same event less the earliest allowable time for the same event also, and it's always equal to either a positive number or a 0. If you would like to calculate the critical path on a Pert network drawing, is by looking at all the arrows which have the slack value equals to 0. As we have done it by our eyes quickly, we looked at all the arrows where all the events had a slack variable or a triangle with a 0 amount inside it. The critical path, path stands for it is the longest path, or the longest allowable time for the project. Okay, and it's also the project time. Okay, the different paths when you are asked to calculate the time or determine the different paths on your Pert network, you'll find that there are different paths, and you can just understand them, or analyze them by writing the activities and looking and following the arrows in the right direction. Okay, you can have different paths. Also, if you are asked to determine different crashing plans, you have to take care first to crash activities one by one with the lowest cost per day or weeks, and also the number of days. Secondly, if you have to crash the critical path first, and then you start to find the second path or another path, more than one path, are having the same amount of days after crashing. So you have to make the critical path first, crash it until it is equal to the next path, then start crashing them together as we have seen in the problem. Okay. Thank you. That's it for this time, and we'd love to see you next time. Goodbye.